Now that we've done some with confidence intervals, we're going to talk about another approach that we can take about this. Essentially, our idea is we know what we want our margin of error to be, and so we need to pick an appropriate sample size to deal with that. So I'm going to let E denote my margin of error, and if I know what this value is, then I have this formula to determine the appropriate sample size. I multiply my Z value times my standard deviation, divide it by E, and then square it. And with these, it's always important to round up. Let's look at an example. Let's suppose we want to estimate GPA within 0.1 with a 98% confidence, and we know our standard deviation is 1.2. So I know sigma is 1.2, and I know my error needs to be 0.1. We also need a value for Z. In this case, I have 1 minus 0.98, which is 0.02, and then we always divide this number by 2 to get 0.01, so I need to find the Z-score that estimates that. So here's our Z table. We need to find 0.01, which we can see this right here, this 0.0099 is going to be the closest, which is negative 2.33. Coming back to our example, we now know that Z is 2.33. So our formula for sample size says to take Z times our standard deviation divided by the error and square it. When we do this, we get 781.76, and when we're dealing with population size, we always need to round up. So if we want to estimate this within 0.1 with a 98% confidence, we need to talk to at least 782 people.